Yeah, in the last video, we saw how to read elements, access elements using load word. We saw element by element. Now let's assume if you have a question, initialize an array of 3 integers or 5 integers or a certain number of integers, and you are going to read the array elements and print the array elements. So you are going to do this this in one program. For example, let's assume initialize maybe 3 or 5, whatever is it. So in data directive you will be doing initialization. Let assume let's say the A is the name of the array and integers, so data type is word, and 3 elements initialize any values, let's say 10, 20 and 30. So this is initialization. Now I'm going for a text directive to read and print them. To read you will be using the load word, but last exercise we saw load word element by element. We can't do it. I need a loop, because if you have 3-5 elements you can manage one by one. Let's assume if you have 50 elements or 100 elements, you need a loop. So I'm going for a loop. Basically for a loop you need counters, starting counter, ending counter. So let's assume maybe T1 is the starting counter and T2 is the ending counter. Let's assume I have 3 elements. Okay, so let's assume 3 elements. So this is starting counter and this one is ending counter. One more thing I need is base address. Let's assume S0, register S0 is the base address. So this is base address. So these are the 3 things I need before I start the loop. So now let's start the loop. I need a label and the as usual loop beginning. So let's say T1 starting counter, T2 ending counter, exit. Okay. Now I need to load the value, then I have to print. The question is read and print. So for reading I will be using load word. So load word, I'll put it in any register. Let's say T0, I'll load the element from the array to this register T0. So here you might have learnt in the last exercise, last video, load word, how to do load word. So LW and a register and offset, inside the bracket we will be writing the base address. You know the base address, it's in register is 0. So offset. In the last video I mentioned offset differs for each element. First element offset is 0, second element offset is 4, and next element offset is 8, 12, 16, it goes in the increment of 4. In a loop I can't do that. I need a fixed, because in a loop the statement will be executed quite repeatedly. So here I can't change the offset. So what I'm going to do, let's keep the offset 0 and I will increment the base address 4 by 4. Okay, let's do it. So I load the first element to T0 and I load it and I print it. So you know how to print integer. V0, 1, move register A0, T0 and syscall. This is for printing. By the way, this will print in a quite straight line. You need a \n to print one by one. Okay. So what I do, I start the loop and then I load the first element and I print the first element. Now I'm going for the second element. So increment. So increment the counter. Which is the counter? T1 is the counter. So T1, 1, and then increment the base address. So every element goes in an increment of 4. So increment the base address by 4, which is S0, 4. I don't have anything now, so jump loop. So this will go back here and it will repeat the same thing for the second time. Fine. So first element it will be 0 and the base address. For the next element, it will be by 4, because S0 is incremented by 4 here. Okay then, so the exit comes below the jump loop. This is the exit. When the condition becomes true, it will come straight away here. Okay, you can continue the rest of the program here. Okay then, so this is how to read and print the values. Now let's see how to here I'm on the previous one is I read from the array and initialize. In the previous example I initialize. Now I'm going to, let's say question is read the values for the array for an array of 5 integers. I'm going to read and print them all. Let's say print them. So printing you know already. So I'm not going to bother this printing because you know already. Now I'm going to read the values for an array which is going to have 5 elements. No initialization, reading from user. Fine. So in the data directive, initialize an array. Don't assign any value. So no initial, in the data directive, declare an array, do not initialize. So declare, I need the storage type called space and I need to mention number of bytes required. I already mentioned in the previous video how to calculate. So what is the size of an array? 5 elements. So 5 times 4, that is equal to 20. So we'll write 20 here. In the text directive, I'm going to read. So 5 elements. I can't do one by one. I'll write a loop and in the loop I will be reading one by one. Okay then. So like in the previous, the loop has some basic things. You need to initialize something. So counter as usual. So let's say T1 is the starting counter and T2 is the ending counter. Let's say 5. So this is the starting counter and this is the ending counter. Okay, as usual you need the base address. So let's say this is the base address. Now I'll start the loop. So this is the label, branch greater than, starting counter, ending counter. Let's say exit 1. Let's assume it's exit 1. Fine. Now I need to read value from user and store it onto the array. So what I'm going to do, read from user and store in array. Okay, reading from user, register li v0, 5 syscall. When you do this, it will read a value and the value read will be in register v0. So v0 contains the value, whatever the user typed in. I'm going to move that value to the memory. So the v0 value goes to memory. I'm going to use now store word. Store word, move the value from register to memory. Okay then. So remember, store word means register to memory. So this is the concept you have to remember. Register to memory. Okay, fine. So as usual, the previous example, you keep the offset 0. Base address is S0. So in this way, you are reading and you are straight away storing it onto the array. Read and store. So I'll do for 5. So the loop will be executed for 5 times. Now increment the starting counter T1, T1, 1. Increment the base address. Base address S0 is incremented by 4. Then jump loop 1. So this jump loop will go to the loop 1. Fine. So first time it will read a value, store it into the memory, array. Next it will read the second number, store, and read the third numbers, and it will be executed for 5 times. So now I finished one task, reading values for the array. Now I want to print the values for the array. Again I need a loop. Okay then. So this exit 1 I'll be using for the exit 1 for the next loop for printing the values. Fine. Again I need to initialize few things. I need the starting counter T1, 1, ending counter which is T2, 5, base address. Let's assume this time T0, A. So this is the starting counter, ending counter, and base address. Start the loop again. This time let me call it loop 2, and same loop, branch greater than T1 and then T2. This time I label the exit 2. This is the new label. Okay. Now I read from the array, that means memory, and I print it onto the system, like a console, standard output screen. Okay. I read from the memory. So load word. So this time I will be using load word. So printing, how do I go? How do I do the printing? V0, 1, load word. I'll try to use this one. This is fine, possible. Offset and then base address 0 and then base address T0. So what I'm doing, I read the element from the array, move to register A0, then syscall. This is one shot, you can do it. Remember, load word means memory to register. I load the value from memory to a register. Any register you can load it. Remember this concept. So what I'm doing, I am loading the value and I'm printing it. I'm doing everything one shot. After I print, as usual, you need the increment. Starting counter is incremented by 1 and the base address is incremented by 4, and then I don't have anything to do, so jump loop 2. This is loop 2, loop 2. So it goes in this loop, don't go to the other loop. Okay then. And this exit, here I use the exit, so here it is. So this exit comes here. If you have anything, you can write it. If you don't have anything, let's finish the program. Syscall to exit the program, terminate the program. Fine. So what are we doing here? Here we remember, whenever you start a loop, you need to have this initial parts. You have the starting counter, ending counter, base address. So you need these things. Then you start the loop. Okay, this should not be repeated. This should be done only once. You should not repeat these things. Okay, and then you start a loop. And in the loop, here I am printing. I am reading from the memory, that means array, and I print it. And I increment the counter and then increment the base address and jump loop. So this is the second part. Fine, that is for printing. Remember, load word to move the value from memory to register. So I'm using it here. So this is for reading from the array and printing onto the screen console, standard console. Okay, thank you.